Hello everyone, in this video we're going to be solving a geometry puzzle, a sangaku problem. We have a square, and as you see, the midpoint of one of the sides was connected to a vertex and the two vertices were connected to form the diagonal, and we inscribe a circle in the triangle formed. So we're going to find the radius of the circle r in terms of the side length of the square, which is a. At this point, you can go ahead and pause the video and then take a look at the solution. Okay? Alrighty. So let's get started. Well, we're going to be taking advantage of many interesting things in geometry. First of all, we are going to work on finding the area of the triangle. And I'm going to tell you in a little bit why we need the area. Okay, so first of all, notice that we can actually find the side lengths of this triangle. How? We're going to take advantage of symmetry, right? We're actually going to be using similarity here. So let's go ahead and do that. So how does that work? So suppose this is A, this is B, this is C, this is D, this is E, and this is F. So I'm just saying that triangles ABF and CFE are similar. And the similarity ratio is actually going to be 2 to 1. So what that means is that we can find the side lengths if needed, or we can actually find something more interesting, which is the height. Now, why do we need the height? So let's go ahead and outline the solution here. We're going to go ahead and find the height of triangle AFB, and then using the height and the base, we're going to find the area of triangle AFB. And how does that help? Well, if you think about the circle, that's the inscribed circle, which is the in circle. So there's a relationship between the in radius and the area of the triangle. So let's go ahead and proceed. Now, the first thing I'm going to do is I'm going to draw the height of the triangle. Of course, we're talking about two triangles here. Let's go ahead and connect them like this. And what we know about the heights is that the heights are also going to be divided up in the ratio of 1 to 2. And the whole thing is A, as you know. So this is going to be A over 3, and this is going to be 2A over 3 with the height of the lower triangle. Now, I'm going to go ahead and write the area from here. Okay? So the area of the triangle ABF is equal to 1/2 times base times height. Okay? The 2 cancels out, and we get from here A squared over 3. So the area of triangle AFB is A squared over 3. Now, how does that help us? Well, if the radius of the circle, which is the in radius, is R, then we have this interesting relationship. We can find the area using the in radius. How? Well, if you multiply the perimeter by the radius, you're going to find twice the area. In other words, the area is equal to semi-perimeter multiplied by the in radius. That's what we need. So what is the semi-perimeter? Well, the semi-perimeter is going to be the side lengths added up and then divided by 2. So let's go ahead and do that. What are the side lengths? Okay, then we need to find AF and FB. How do you find AF and FB? Well, AC is the diagonal, which is A root 2, right? And AF is going to be 2/3 of that. So it's just going to be 2 root 2 over 3 multiplied by A. Okay, so we can find EB from Pythagorean Theorem. As you know, EB is the hypotenuse of ECB. So EB squared is equal to A squared over 4 plus A squared. From here, we get EB squared is equal to 5A squared over 4. And EB is going to be root 5 over 2 times A. Now, we do know that FB is going to be 2/3 of this. Let's go ahead and multiply this by 2/3. And that's also going to simplify. So FB is going to be root 5 over 3 multiplied by A. Now, we got FB, we got AF, we got AB. We can find the semi-perimeter. The semi-perimeter is just going to be the sum of those lengths, right? Which we found. And then FB, and then AB, which is A, right? AB is equal to A here. Awesome. Let's go ahead and plug those in. So for the semi-perimeter, we're going to be getting, let's go ahead and write it down here. I'm going to have 2 root 2 over 3a plus root 5 over 3a plus a all over 2. And then that's going to be multiplied by the radius. Okay? Okay, let's go ahead and simplify this a little bit. Make a common denominator. The area is going to equal 2 root 2 plus root 5 plus 3. And then the whole thing is going to be multiplied by 6 because, divided by 6 I mean, because that's divided by 3. And then this will be multiplied by r. And then as you know, this area is just going to equal a squared. And of course, there's an a here too, so let's not forget that. Let me go ahead and erase this. This multiplied by a, and that is going to equal a squared over 3. Now, this a is going to cancel out, obviously. So from here, we can actually solve for r. R is going to be 1/3 multiplied by the reciprocal of this expression, which is 6 over 2 root 2 plus root 5 plus 3. And then, of course, we have an a here, so that's just going to be 6a. Because we were trying to find r in terms of a, we actually found. So let's just simplify this a little bit. So that's going to be a 2. So r is going to be 2a divided by 2 root 2 plus root 5 plus 3. So that's going to be our radius in terms of a. Thank you for watching. Please comment, like, and subscribe. See you in the next video. Bye-bye.